So we're going to apply Rolle's theorem to this problem. Rolle's theorem states that if f is continuous on a closed interval and differentiable on the open interval, and if f of the interval being a, b, and if f of a equals f of b, then there has to be at least one number c inside of ab such that the derivative at c of the function equals 0. So basically what it says is, for this example, if they're giving me this closed interval and this open interval, here we've got a continuous function, and notice that it's a cubic because there's a first degree there and a second degree there, and it's a positive leading coefficient. So it's doing something like this. And we know the zeros are at 3 and at -1. There's a double zero at -1, so that must be this one. Well, I guess it could have been this one too. I'm not sure, but let's say it's going to probably be something like this. There's your -1, there's your 3, there's your x-axis. Got it? Let me redo that. There's your x-axis. So your y-axis, what would your y-axis be? If I plug in 0, your y-intercept rather, -3, it'd be -3. So it's going to be something like this. There's -3. It's probably not going to be that point, but so the point is this, that the Rolle's theorem says that there's going to be some value on -1, 3 such that the derivative at that value, some c, is equal to 0, meaning it has to turn at some point. So it's got to turn somewhere in here. It's got to turn so that the derivative at that point is 0, which means there's a horizontal tangent line. Does that make sense? That's the idea behind Rolle's theorem. So how do we find it? Well, first of all, we have to verify that it's continuous and differentiable, and it is. I don't even have to go much into that. I think you can tell that it is, right? So then we have to take the derivative. So we're going to find f prime of x. Now, there's two ways you can do this. You can either use the product rule, or you can expand this out, f of x out, and then just use the power rule. I kind of would prefer to expand it out myself. So let me just do that. It's easier for most people. So f of x equals x minus 3 times x squared plus 2x plus 1. And now FOIL that out more. So x cubed plus 2x squared plus x minus 3x squared, distributing the -3, minus 6x minus 3. Simplify that. That's x cubed. Those add together, minus x squared. Those add together, minus 5x minus 3. It didn't take that long to do. And so the derivative of that is really easy now. Just use the power rule. There I go. Now let's set that equal to 0. So how do I solve a quadratic equation set equal to 0?
Factor.
I factor. One of the things that you might remember is the master product is -15. Does -15 have factors that add to -2? It does. So that means it does factor. Now, I don't like factoring with the master product rule. I like just using guess and check. But I know it factors. So it's got to be 3x and x. And then it's got to be -5 and +1. But which goes where? Well, -5 would have to go here, and +1 would have to go there. That way, that gives me -5x, and that gives me +3x, which add up to -2x. Factoring. Learn to do it. It's very important. So therefore, x equals 5/3, setting each one of these equal to 0. X equals -1, and x equals 5/3. So which one of those is on that interval?
5/3.
We knew -1 was going to be there, didn't we? We knew that had to be there because we knew it bounced because of the double root. We knew it had to bounce there. So you know that's going to have a asymptote, or a tangent line
But that one's not included.
But that's not included, that's right. And so this one is the one that you want for the answer.
Okay.
So your answer is find the value of x. So the value of x is 5/3. Rolle's theorem.